So in this video, we're going to deal with trigonometric integrals again, and we're going to deal with products of powers of sines and cosines. But in this case, I'm going to assume m is even and n is odd. So if m is even and n is odd, we can solve it using this case 2. Now, if they were both odd, then I would just revert back and do case 1. But here is just if m is even and n is odd, then we can use this trig identity, cosine squared x equals 1 minus sine squared x, and that way we can actually replace the cosine squared x with 1 minus sine squared x. And then what we would do for a u substitution is let u equal sine x, and then du would be cosine x dx. Now on this example, you'll notice here that I have sine is raised to the 4th power, so the power of sine is even, so m is even. And then here I have the cosine is raised to the 3rd power, so that's actually an odd value, so n would be odd. So this satisfies the conditions for case 2. But the problem is, notice here that my argument of both of these functions are 2x. So I need to do a substitution here. I need to do a little change of variables here so that I can get this in the form of sine 4th theta times cosine cubed theta. In other words, I would just have a single variable here. So what I'm going to do is I'm going to let theta equal 2x, and then d theta would be 2dx. Okay, so now on this, so here's my original, there's my original integral. Okay, now I'm going to let theta equal 2x. The reason I don't want to let u equal 2x here is I don't want it to be confused with a later substitution I'm going to do. So that's why I'm going to use theta. So if I let theta be 2x, then d theta must be 2dx. So that means I need to multiply dx by 2 so that this part right here is my d theta. And if you multiply the inside by 2, you have to counteract that by multiplying the outside by half. So now I can replace the 2x here and here with theta, and then replace this with d theta, and I'll get 1/2 times sine 4th theta times cosine cubed theta d theta. So I'm just going to copy it down here right now, so that's just the same integral that I had up there. But notice what I'm going to do for the cosine cubed theta. I'm actually going to factor a cosine theta out of this and put it with the d theta. Okay? And that's going to come in to help me in a minute. Now that means I have sine 4th theta times cosine squared theta because I factored one of the cosines out. And so now right here is where I can replace the cosine squared theta with 1 minus sine squared theta. And now I can let u equal sine theta, and du would just be the derivative sine theta times d theta, so du would be cosine theta d theta. So you can see now that actually here cosine theta d theta is exactly du, and then since sine theta is u, I would have u to the 4th times 1 minus u squared. So that would give me 1/2, have to bring the 1/2 down, I have u to the 4th times 1 minus u squared du. And then I'm going to go ahead and distribute the u to the 4th through, so I get 1/2 the integral u to the 4th minus u to the 6th du, and then just apply the power rule to each of these terms, and I get u to the 5th over 5 minus u to the 7th over 7 times 1/2. And of course when I multiply each of these by 1/2, the denominators will double, so I'll get the first term will be over 10 and the second term will be over 14. And then I'm going to replace u with my substitution I used here, sine theta. So I actually have sine theta to the 5th power here, and I have sine theta to the 7th power here. And then I've still got one more last thing I got to do. I've got to replace the theta with the original substitution, which was 2x. So I actually have sine of 2x to the 5th power over 10 minus sine of 2x to the 7th power over 14, and then add the constant. And so there's your final answer right here. Okay? And so that's the case where m is even and n is odd, or where the power of sine is even and the power of cosine is odd. So that's how you deal with that. Now I would say here that, let's say just for instance, let's just think about something for just a minute. Suppose this was cosine fifth theta. Well, then you could still factor the cosine out here, and this would be cosine fourth theta. So you would end up with, since it's cosine fourth theta, you could say, okay, that's cosine squared theta squared. So then you'd still replace cosine squared theta with 1 minus sine squared theta, but you'd have a square outside the parentheses. Kind of like I had on the last example, except for it was with the sine example. So anyway, that's how you deal with these types of problems. So in the next video, I'll do the third case where both m and n are actually even powers.